Good morning students. Thank you very much students for clicking on my video. I am your Nagini ma'am, chemistry mentor. In today's section I am going to discuss about the derivation of integrated rate equation for the rate constant of first order reaction. Okay, in the previous section I discussed zero order reaction students, integrated rate equation for the rate constant. For zero order reaction we calculated and half life also calculated. So in today's section I am going to discuss about the first order reaction rate constant and half life I am going to calculate students. Okay, so first of all I am going to calculate the rate constant. See students, so first of all I am taking, just consider one reaction, Nana. Consider reaction. Reactants gives products. Okay, R means reactants gives the products. So we know that rate is mainly depends on the concentration of the reactants, correct or not? Rate depends on the concentration of the reactant. Concentration of the reactant students, correct? Concentration of the reactants. Now here rate, how to write on a formula? Rate is equal to K into concentration of the reactant. It is depends on the concentration. Square bracket indicates concentration of the reactant. It is the rate constant or proportionality constant or velocity constant, or we can say specific rate of the reaction. Okay, Nama. So we here it is a first order reaction now. So that's why I am going to take order value 1. Okay, now power 1 I am taking. In zero order I took 0. This is the first order now, so that's why r power 1 I am taking. K into r dash. Okay, number K into r power 1. Now r is equal to K into r. So this is the equation 1. Now once another formula of rate. What is the rate? Another formula students. We know that rate is equal to minus dr by dt. Correct? Because dr by dt is nothing but decrease in the concentration of the reactant per change in time. D indicates small change, minus indicates the decrease in the concentration of the reactant. We know that generally in any chemical reaction the concentration of the reactants gradually decreases, product concentration gradually increases, Nana. So that's a minus dr by dt. This is equation 2 students. Okay, Nama. Now from equations 1 and 2, what we can write this here in the place of rate, I am taking r is equal to minus dr by dt students. This is the equation 2. Okay. Now from equations 1 and 2, from equations 1 and 2, what we can write students? From equations 1 and 2, left hand side both are r's only, so that's a right hand side part I am taking equal. So that's a what we can write students? K into r is equal to this one, and the second question in the second equation minus dr by dt. Clear students? K into r. Now r terms all are taking one side and constants dt taking one side students. See here dr by r is equal to minus k into dt. Clear this one? Minus, understanding, Nana? So dr is equal to what we can write students? Dr by r. Dr by r is equal to, okay, minus k into dt. Now this one integration applying students on both sides. Now integration, now apply integration on both sides. So when we applied integration on both sides students, d of r by r is equal to integration minus k into integration of dt, correct? Integration of d of r by r is equal to minus k into integration of dt. Clear? Now apply integration students. Integration of d of r by r is equal to minus k into integration of dt. We know that integration of dx by x is equal to students log x, nama. So we can take it as ln x. Okay, nama, ln x. So that's why here what I am taking, dr by r is equal to ln r. Are you understanding? So ln r. So what we can write this one? Ln r is equal to minus k into t plus integration constant I. Integration of dt t plus integration constant I. Okay, now I want to calculate I value students, integration constant. This is the equation 3, Nana. Now I am taking initially Okay, na initially reaction not started, so at t equal to 0. So initially at t equal to 0, then what about ln r, students? Ln r is equal to, it is equal to the initial concentration of the reactant. So that's it, this t equal to 0 and this value ln r equal to ln r naught. So these values here substitute, then you will get the I value. So okay, na, so substitute t equal to 0, ln r values, clear this one, values in equation 3. Clear, students? In equation 3. Now substitute, Nana, what you will get in equation 3? Substitute Nana. So here ln r place, what we will get? Ln r naught, t place, so 0. So substitute, Nana, what you will get? Ln r naught is equal to minus kt plus I, minus k into t value how much, students? 0 plus I value as it is you have to take. Understood, amma? These values we substituted in the equation 3. ln r is equal to ln r naught. Okay, na, t equal to 0, ln r values, ln r naught to this t equal to 0. So minus k into 0 plus I. Understanding, students? After this one. Okay, now see, students, so ln r naught is equal to minus k into 0 plus I. So what we can do for, after this, ln r naught is equal to ln r naught. R naught is what, students? Initial concentration of the reactant is equal to I. Okay, nama, I, this is 0 na, the I value we got. Now this I value, suppose I am taking, this is the fourth equation. Now substitute for in equation 3. Substitute. Okay, na, I value here substitute, Nana. In equation 3 substitute I value. Okay, now what you will get? What is third equation? Again I am writing ln r is equal to minus kt plus I. So fourth one I substituted this one in this third equation. Okay, now I value ln r naught, here you have to take ln r is equal to minus kt plus I value ln r naught. Understanding? Ln r naught. Okay, Nama. So substituted. Now kt is equal to what we can write, students? Kt is equal to, this is right hand side, it is coming to the left hand side, plus it will become plus ln r naught by minus ln r. Clear, Nana? Ln r naught minus ln r. Okay, next. K is equal to what we can write, students? Ln kt is equal to ln a minus ln b, ln of a by b, correct? Ln of r naught by r. Yes, Nama. So what is the formula, students? Ln, here since formula is ln a minus ln b is equal to what is the formula? Ln of a by b. Clear, Nana? Ln of a by b. So that's why use this formula ln of r naught by r. Next kt, this is kt is equal to, now k is equal to, kt is equal to, this is ln kadama. So this ln I am going to convert into logarithm. So that's why we have to multiply with 2.303 into log r naught by r. Understanding? Log r naught by r, Nana. So this kt, this is the kt value. Kt is equal to 2.303 into logarithm of r naught by r. Now k is equal to what we can write, students? 2.303 by t into logarithm of r naught by r. Clear this one? If suppose I am considering equation, Nana, reactants gives the products. Now initial, here r naught to here r. R naught indicates what, students? Initial concentration of the reactant. This is the final concentration of the reactant. Okay, now suppose I am taking here initial concentration at t equal to 0. Initial concentration A, product concentration is 0. Okay, now at time t, initial final concentration of the product, what is the product concentration? If suppose x increased, then reactant concentration is decreased by A minus x, correct? So product concentration x increased, then what is the final concentration of the reactant? A minus x you will get. Okay, now these values here substitute, students. Okay, see here 2.303 by t, here I am taking once again reaction. So K is equal to 2.303 by T into logarithm of R naught by R. Kada? So R naught is initial concentration of the reactant. How much, students? Initial A. So take that value 2.303 by T into logarithm of R naught value A. R value how much? Final concentration of the reactant A minus X. So this also we can write. So this is the first order reaction rate constant. Clear this, students? This is the first order reaction rate constant completed. Now I am going to discuss the graph, students. See here, what is the graph, Nana? From which equation we are taking the graph? From this equation I am taking the graph. So here this equation is there, na? This equation, this one. So this equation you take ln r is equal to, from that one I am going to discuss the graph. Now see, students, ln r is equal to what we got? Minus kt plus ln r naught. I think what is ln minus kt plus ln r naught. Understood, amma? So from this equation I am discussing the graph. This is in the form of y is equal to mx plus c. Y is equal to mx plus c graph. Now see, students, y is equal to mx plus c graph is like this. Y in the place of y, which one is there, students? Ln r. That means along y axis I am taking ln r. Along x axis, in x plus t is there. So that's why along x axis t I am taking. And what is the slope, students? M is equal to minus k. And what is the c intercept? Ln r naught. Ln r naught. Clear, students? C value ln r naught. Y intercept means this line where touches the y axis, that is calling as y intercept. So this is the first order reaction, students, completed. Now I am going to discuss about the half life of the first order reaction. What is the half life of the first order reaction? We have to find the first order reaction half life. Okay, how to find it, Nana? Half life of the first order reaction. See, Nana, what is half life? First of all, T half. It is represented by T half. What is T half, students? The time is required to complete the half of the reaction. The time is required to complete the half of the reaction. To complete the half of the reaction, how much time is required? That is nothing but T half, students. For example, A to B I am taking. A is initially 100%. Now to complete this reaction 100%, now first initially to complete the half of the reaction means 50%. To complete the 50% of the reaction, how much time is required? That is nothing but T half. Are you clear this one? So to become 100%, as 50%, how much time is required? That is nothing but T half, students. Okay, Nama? So T is equal to T half. Now I am taking the first order reaction. What is the first order reaction main formula, students? This one. K is equal to 2.303 by T into logarithm of A by A minus X, or otherwise you can take this also, Nana. Okay, na R naught by R or A by A minus X also we can take. Understanding? So I am taking this one or this one, any one formula, students. See here, K is equal to 2.303 by T into logarithm of A by A minus X I am taking. Okay, na? This is the first order reaction, correct? This is the first order reaction I am taking. Now here T is equal to how much, students? T half. T is equal to T half, and A is the initial concentration. A minus X is the final concentration of the reactant, correct or not? Here we discuss, Nama, A is initial concentration of the reactant, A minus X is the final concentration of the reactant. So that's why R naught plus A, R plus A minus X we took. Okay, now see, students, logarithm of A by A minus X there. So this is initial concentration, this is final concentration. Initial means 100%, final concentration of the reactant should become 50%. Are you following? That means 50, how we got Nana? Initial by 2. Initial concentration 100 by 2. Half we calculated, then you will get 50. Understanding? So this is 50%. Means how we got 50? Initial concentration by 2 we done. We will get the 50%. So like that only, it is initial concentration. This is final concentration. How much final concentration? A minus X is equal to, it should be equals to half of the initial concentration, A by 2. Correct or not? So this is the final concentration. This is the initial. So final concentration of the reactant is equal to the half of the initial concentration, A by 2. Clear now? So logarithm of A by A minus X. So T is equal to T half. That means to complete the half of the reaction, how much time is required? That is nothing but half-life. T is equal to, I am taking as T half. This is A minus X. This is the final concentration. A minus X is equal to, initial concentration. Half of the initial concentration. Clear Nana? So A minus X is equal to A by 2. So this value here substitute Nana. Okay. Now how much you will get? K is equal to 2.303 by T means T half. In place of T half, logarithm of A by A minus X. A as it is, A minus X value how much, students? A by 2. Okay na? A by 2 we have to substitute. Now A get cancelled. So K is equal to 2.303 by T half into log 2 value will go to the up. Now how much Nana? K is equal to, what we can, how to find this? K is equal to 2.303 by T half into log 2 value 0.3010. Now multiply this one, 2.303 into 6.3010, you will get 0.693 by T half. Actually what we should find? T half value we should find. Then 0.693 by K. Understanding? T half is equal to 0.693 by K, students. This is the half-life of the first order reaction. Now see students, in the half-life, is there any reactant concentration, students? Initial concentration of the reactant is there? A naught term is there, amma? Not there. Are you clear? But zero order reaction half-life, what students? T half is equal to A naught by 2K. Correct? That is, this is the zero order. Clear this one? This is zero order half-life. So zero order half-life, it depends on, here A naught term is there. Here A naught term there, not there. So that means T half depends on A naught in case of zero order. In case of first order reaction, T half is independent on the initial concentration of the reactant. Correct or not? Here T half is depends on A naught. Correct? Initial concentration of the reactant. Here T half is, it is independent on A naught, because here A naught term only not there. Correct? So that's it is independent. Understanding, students? Right? Finally one sentence. Half-life of first order independent on the, clear? It is independent on the initial concentration of the reactant. Initial concentration of the reactant, students. Clear this one? Understood, Amma? So in questions also, in problems, how they will ask Nana? So directly they will not ask Nana. It is calculate the T half for the zero order, calculate the T half for first order. They will not ask. So what they will tell? If the half-life of the T half value, if the T half is independent on the initial concentration of the reactant, that means what we can understand? That is the first order reaction. T half value you have to take. If suppose T half value is depends on the concentration of the initial concentration of the reactant, then that is the zero order reaction. Are you understanding, students? You have to remember this two, very very important. So zero order, in case of zero order, T half is depends on A naught. In case of first order, T half value it is independent on A naught. Clear this one? Okay students, I hope you like this video. If you like this video, please like, share, comment and subscribe my channel, Nana. Thank you very much students.